Howdy cow folks, Mr. Norman here. We're going to go over section 1.2. I see that a couple of you have already done it, and that's fine. The actual math of it's pretty easy. We're mostly focusing on definitions. So I will be uploading this document. I don't know if it's going to be this document or PDF, but I'll be uploading this to the class stream when I'm done, along with posting the video. That doesn't mean you don't need to take notes. Writing notes is one of the best ways to know the information. So we're going to start off with the ruler postulate. So the most important thing right now is to know what a postulate or axiom means. You can read this yourself. It's on Big Ideas Math. It's also, like I said, going to be posted. So the important thing to know is that a postulate and axiom means a truth or rule. It's something we don't prove. It just is. So an example of an axiom that we have inside of mathematics would be something like, an example of an axiom in mathematics would be something like 0 plus 1 equals 1, which is the identity property. That's axiomatically true. There's no way to prove it, because by definition, that is what 0 means when you add. But that's a bit of an abstraction. The important thing to know is that an axiom is something that's true, something we don't prove. So on to the axiom real postulate. The points on a line can be matched 1 to 1 with the real numbers. What does that mean? It's this thing. It's a number line. So we can draw points on a number line. That just means we can draw points on a number line. That's what it means when it says it corresponds to a point. Oh, sorry. That means it can be matched 1 to 1 with real numbers. So -3, -5 to 3. So here we'd have another point, a sub 1, -4. Maybe here we have point D, because it doesn't really matter. This would be 0. It just means you can make your points. You can make a line, add points, and have a number line. So we have a number line. Another way you can think of it is a ruler, because rulers have numbers on it. It goes from a line to numbers. That's a terrible drawing of a ruler. It looks more like a baked potato or a bald person's head in a cartoon. So important thing is the first part of this is saying it's a number line. So the next thing is saying that the real number that corresponds to a point is the coordinate of the point. Simply means if we take these two here, -5 is the coordinate of A, which makes sense if you think about it. We're used to our numbers, our points having a coordinate. Normally we think of it more like an axis with 2 points. I don't know, this could be like 1, 2. Well, this is a coordinate. It's the same thing here, but instead of having 2 number lines, we just have 1. And yes, a coordinate plane, or the Cartesian coordinates, are just 2 number lines that intersect each other. So now for the bit more juicy thing, the distance between points A and B, written capital AB, notice there's no line above this. This is the same way that the distance formula is written, is the absolute value. Absolute value has 2 bars. Absolute value. Those are the absolute value bars. All that simply means is whatever is in here, whatever number you put in there, turns non-negative. So if you put in -3, it equals 3. If you put in 0, it equals 0. Put in 2, it equals 2. And also, if you have an operation, 2 minus 3, that equals absolute value of -1, which equals +1. And if you have -6 times 3 equals -18, which equals 18. So to find the distance of something, we subtract. If I want to know how far apart these numbers are, I'm going to take the final number and minus the initial number. What this rule says, the rule of postulate, is that you put this in the absolute value to get your answer. So minus a negative turns into an addition problem. So 3 plus 5 is 8. So since we put in the absolute value, it doesn't matter which number we put first. So -5 minus 3 equals -8. Absolute value -8 is 8. These are the same. This also shows us that distance is never negative. Never negative. You may be thinking, what do you mean? I can go a -5 feet. No, you can't. You can go in a negative direction, but you can't go in a negative. Sorry. Yeah, you can go negative direction, but you can't go negative distance. And what I mean by that is, think of a person that is -5 feet tall. You can't do it. It doesn't happen. You can go a negative direction. You can walk backwards 5 feet, but the backwards is what's negative, not the distance. Yes. Okay. So the rule of postulate, whenever you see number lines or you're using absolute value, you're using the rule of postulate. Next, we're on to the segment addition postulate. Please notice that it says segment and addition. Segment. That's a segment. Segment. Line segment. Addition. Combining. Adding. So with 3 collinear points, it has to be collinear. Has to be collinear on the same line. If B is between AC, you can use the postulate. Notice this is not collinear. That means it doesn't work. So here's an example as to why. So here, I have a collinear point. I have 3 collinear points. We can say that this is 1, this is 2, so the whole thing is 3. Here, this actually creates a triangle. D, E, F. So this is 3, D to F. This is 1.2, and this is 2.4. Which means that this length, if you go up and then back down, is not the same as the length directly through the points. Okay, so if b is between these points, you can combine your terms. So notice that this has three parts. We have AC, AB, and BC. What we can do, remember that when there's no bar on top, this represents a distance. So what do we do when we have distances? Distance is just a number. So we can write a formula. So if we have something like this, that means we can very easily rearrange the formula to find other parts. So if we know AC and AB, we can find BC. I'm gonna have another video with the modeling progress on it. So you'll see some example problems that you can work, and then I'll work them out for you. Right now we're just going over the postulate. The other video for modeling progress will actually have all of them. It would be easier on you if I had them where the modeling progress was in between all of them. But right now, for my current circumstances for recording, this is a lot easier. Okay, but I'm sure you'll get it. If you have any questions, as always, please contact me. The last chunk we have are congruent segments. Notice very carefully. On this one, it's a distance because there's no bar. On this one, it's a segment because there is a bar. So line segments can have the same length. They're called congruent segments. Here, again, same length is a distance. Congruent segments. Oh, that's not going to work. Congruent segments are talking about a geometric object like a shape or a liney thing. You can say the length of segment AB is equal to the length of segment CD, or you can say segment AB is congruent to segment CD. This symbol, which is a little blurry, is this one. It's congruent. It has a squiggly line on the top. The technical term for that squiggly line is a tilde. If you know a little bit of Spanish, you can recognize that. So this is the congruent symbol. That's the symbol that's here. That's the symbol that's here. This is just the equal sign. Ain't nothing new. You've been seeing this all your life. So what it's saying here, we can say the length of segment AB is equal to the length of segment CD is actually the first section. The distance is equal to the distance. The second part is saying that the segment is congruent to the segment. Remember, congruent has to do with shapy, liney thingies. This has to do with numbers. This has to do with numbers. Which means I can say 2 is equal to 2. I can say 2 is equal to 2. I cannot say that 2 is congruent to 2 because congruent does not work with numbers. It works with shapes and images and figures and liney things. I can say this square is congruent to this square. Because congruent describes shape and proportionality. Okay, here are the notes. I will see you at the next video. Oh, wait, no, I almost forgot a very important thing. If segments are congruent, these segments have equal length. Which is the same as saying if the segments have equal length, I can do better than that, or distance, they are congruent. Okay, I'll see you at the monitoring progress. Cat folks out. Peace.